The theory of relativity is the servant of the absolute. Postmodern society preaches and lives relativism. They defend that beliefs, values, and practices should be understood according to the historical, social, and cultural context in which they are inserted. This means that what is considered right or wrong, true or false, can vary according to culture, time, and social group. The maxim is: there are no absolutes, everything is relative. However, when studying and doing science, this maxim is not, and cannot be taken to the letter. Analyzing nature with its fundamental laws that govern it, we find many absolutes from which it would be impossible for life to arise and sustain itself in this universe without them. The same occurs in his studies and forecasts. How do we know in advance phenomena such as eclipses, planetary transits, meteorological phenomena, weather forecasting, tides, and earthquakes? Because we have these absolutes, we are able to build space vehicles and launch them into space, we communicate via satellites, we have thousands of planes taking off, flying and landing. When we get sick, we can take exact doses of substances that cure us or ease our pain. There are so many benefits that I would spend hours here listing them. Let's look at some examples of these absolutes. 1. Conservation laws. The laws of conservation of mass, energy, and momentum are considered fundamental truths of physics. They state that in a closed system, the total amount of mass, energy, and momentum remains constant, even if the way these quantities manifest themselves is altered. These laws are universal and apply to all physical phenomena, from the smallest subatomic particles to the largest cosmic scales. Examples. Law of conservation of mass. In a chemical reaction, the total mass of the reactants is always equal to the total mass of the products. Law of conservation of energy. The total energy of a closed system remains constant, even if it is transformed from one form to another, e.g., kinetic energy into potential energy. 2. Fundamental principles. Some basic principles of physics, such as thermodynamics and classical mechanics, are considered fundamental truths that describe the behavior of nature at different scales. These principles are tested and validated through rigorous experiments and form the basis for many scientific theories and models. Examples. Second law of thermodynamics. The entropy of a closed system tends to increase over time. Newton's laws of motion. The net force acting on an object is equal to its mass times acceleration. 3. Well-established theories. Scientific theories such as Einstein's theory of general relativity are considered highly proven and accepted by the scientific community. These theories have been extensively tested and confirmed through various observations and experiments, and they provide comprehensive explanations for a wide range of natural phenomena. 3. Fundamental constants of nature. Constants such as the speed of light in a vacuum, 299,792,458 meters per second, the universal gravitational constant, 6.67430 to the power of minus 11 newtons, square meters per kilogram squared, and Planck's constant, 6.626607015 to the power of minus 34 joules, seconds, are considered absolute values that do not change with time or location in the universe. These constants serve as basic parameters for various physical theories and are used in calculations and predictions in various areas of science. They are true absolutes of nature. Now, believe me, even Einstein's theory of relativity, which is the icon of liquid and flaccid philosophies of the postgraduate, depends on absolutes. One of them is the speed of light, which is constant. Its value cannot be derived from other physical laws. It is always the same for all observers, regardless of their movement or light source. The speed of light is considered invariant, that is, it does not change with time or with the conditions of space-time. Let's look at just one aspect of the theory as an example. The equation of time dilation. Delta t line equals delta t divided by the velocity multiplied by 1 minus the division between the velocity squared and the velocity of light squared. Where delta t line is the time interval measured by a moving observer relative to a resting observer. Delta t is the time interval measured by the observer at rest. C, it is the velocity of the observer in motion relative to the observer at rest. U, it's the speed of light in a vacuum. Now, if UC, which is the speed of the observer, becomes equal to CE, which is the speed of light, the value of the time dilation would tend to infinity, since the equation would result in delta having divided by 0. The time interval measured by the observer at rest divided by 0. Well, to conclude, I believe that if there are absolutes in nature, and, as we are also part of nature, our society has and needs absolutes for its perfect harmony. I also understand that we need relativism on many important issues for our survival, such as respect for diversity, dialogue and understanding, adaptability and flexibility. These fundamentals are sometimes essential for us to live in harmony. On the other hand, absolutes are also important in many issues, such as universal principles and values that serve as the basis for social cohesion, justice, law, and order. Understanding the existence and importance of absolutes and relativism, finding the balance between both, must be an incessant search for the benefit of all.